Gears and shafts inside a transmission transmit rotating motion. To understand transmission power flow, one of the first things that you must understand is how gears rotate. One basic rule of gear operation is that gears in mesh rotate in opposite directions. To make two gears rotate in the same direction requires that a third gear be inserted between them. Knowledge of gear design is also important when working with transmissions. There are three basic types of gears that you will see in manual transmissions and transaxles. The first is the spur gear. This type of gear has straight teeth. Because spur gears are noisy, they generally are only used for reverse gears on modern transmissions. The most common type of gear found in transmissions are helical gears. The teeth of this type of gear is cut at an angle. This does make them very quiet. However, helical gears cannot be moved in and out of mesh with each other. The final type of gear that you will see in this self-study course is the spur bevel gear. The manual transaxle differential uses spur bevel pinion and side gears. Now that you have seen the type of gears found in transmissions, let's look at how these gears work. Gears are just circular levers. Because of the differences in their diameter, they are used to change torque and rotation speed. Let's see how this is done. Here we see two gears in mesh. They are the same diameter and have the same number of teeth. Since each gear is the same size, they both rotate at the same speed and with the same amount of torque. This is a 1-to-1 gear ratio. However, if we take a smaller diameter gear, for example with 12 teeth, and have it drive a larger gear with 24 teeth, the driving gear rotates twice for each rotation of the driven gear. If the 12-tooth driving gear is turned with 10 pounds of torque, it rotates twice for every rotation of the 24-tooth driven gear. It exerts 10 pounds of torque twice. This multiplies the driven gear torque to 20 pounds. This is a reduction gear ratio of 2-to-1. Now let's look at a drive gear that is larger than the gear it's driving. Here we see a gear with 24 teeth driving a gear with 12 teeth. For each rotation of the 24-tooth drive gear, the 12-tooth driven gear rotates twice. If the drive gear is turning with 20 pounds of torque, the driven gear is only turning with 10 pounds. This is because the drive gear is only halfway through its rotation when the driven gear's rotation is completed. This is called an overdrive gear ratio. To sum gear ratios up, when a small gear is driving a larger gear, it is in gear reduction and multiplies torque. When the driven and drive gears are both the same size, no change in torque or rotation speed is made. This is called direct drive. When a larger gear is driving a smaller gear, the driven gear rotates faster than the driving gear, but with less torque. This is an overdrive gear ratio.